Welcome to Kaiju Mathematics. Today I will be explaining factorial, the exclamation mark in mathematics that is a mystery to a lot of people, but it comes up a lot in statistics, and then it comes up a lot in college algebra and calculus. Factorial is used a lot. And what a factorial means is it does not mean an exclamation mark, but a factorial is notated with 5 factorial or 10 factorial or n factorial. And what a factorial is the number of ways to organize n objects. Number of ways to organize n amount of objects. So n factorial will tell us the number of ways that we can organize n number of objects, or 10 factorial, 10 different objects. So there's two directions that I could take this right now. I could explain what the mathematical operation is behind like 5 factorial, behind 10 factorial, or give you a little bit more background on what a factorial does, and I think I'm going to go down the math route. So let's take a look at what 5 factorial ends up being. 5 factorial is 5 times 4 times 3 times 2 times 1. Now here is why it's 5 times 4 times 3 times 2 times 1. Since it represents the number of ways that we can organize n amount of objects, let's say I have a Rage Against the Machine playlist of 5 songs. And I want to know, well, how many different ways could I organize this playlist? So when I'm creating my playlist, how many songs do I have to pick from for my very first song that's going to play? I have 5 songs to pick from. So now that the first song is picked, now after that first song plays, how many songs are left? 4 songs are now left. And then 3 songs are left. And then 2, and then 1. So it's an operation of multiplication between all of them. 5 times 4 times 3 times 2 times 1. And these numbers really start to explode pretty quickly. But 5 factorial is going to be 120. 5 times 4 times 3 times 2 times 1. But once you get around like 10 factorial, I got my calculator right here. Let me just type that in real quick. And that is a pretty big number. This comes out to be 3628800. And then once you get to like 15 and beyond, like they just really start to expand pretty bigly, pretty quickly. So if you're doing like homework or something in a stats class, most of the time their teacher will accept 5 factorial or 10 factorial in an application question like this, where you're just trying to make sure you understand what type of procedure you're supposed to perform in a scenario like that. So like in a song's playlist, you want to use factorial because it tells us the number of different ways that we could organize the number of songs. One huge area of factorial where people are always just like, not positive, I don't understand why this answer is when we talk about 1 factorial and 0 factorial. 1 factorial is 1. So the explanation is, if factorial represents the number of ways we could organize n amount of objects, 1 factorial is 1, because if we have 1 object, how many ways could I organize 1 object? 1 way. I have a single object. 0 factorial is also 1. How many different ways could I organize 0 objects? 1 way. The absence of objects, if you want to think of it like that. But 0 factorial is 1, and 0 is always this funny number that breaks all these rules, and you can't divide by 0. 0 times anything is 0. There's just all these weird breakdowns when 0 gets present. So you'd think 0 factorial would probably be 0 just naturally, but 0 factorial is actually 1 because we don't have any objects. So how many ways can we organize 0 objects? Just 1 single way. Now this is getting a little bit more calculus based, that you'll use this property a little bit more, but I want to just look at n factorial for a second here. Now if you're in a stats class, you're probably not going to really get into the whole expansion of n factorial, but if you were to break this down a little bit further, n factorial would be n times n minus 1 times n minus 2 times n minus 3, and then 3, oops, let me a little bit higher, then 3 times 2 times 1, just like how I did here, n times n minus 1 times n minus 2, all the way down to 3 times 2 times 1. But that would be the more expansion algebra class, college algebra, calculus type of class that you'd want to know this breakdown, but in a stats class it's more of just the like the actual value of the factorial. So before I close out this video, let me just look at one more example, another type of common scenario that's looked at with factorials. This example is you are visiting Jurassic Park and you want to visit the 5 different exhibits. How many different routes are possible? So a common example with factorial is this type of example. The different paths that you're traveling. Like if you're heading out on some errands and you have 6 different places you need to go, how many routes are possible for those 6 different places? 6 factorial. Same thing here. You're going to an amusement park. There's 5 different directions you can go when you walk in, or 5 different lands or exhibits in Jurassic Park. How many different routes are possible by the end? It would just be 5 factorial. And as I just broke down on the last slide there, that's 5 times 4 times 3 times 2 times 1. And that, again, I just said was 120. So that is an explanation of factorial. Hopefully this helps. Hopefully that now you kind of have a little bit of understanding of applications that could be done with factorial. Thank you so much for watching. Make sure you hit that subscribe button, and I'll see you in the next video.